Welcome back, dear students. Under Algebra and Number Theory, we are in unit number 5, Classical Theorems and Multiplicative Functions. We are now in lecture number 10, which is about multiplication functions. So, lecture number 10, 11 and 12 will be having the entire content of multiplicative functions. Whereas from lecture 1 till 9, we had seen all the classical theorems. The three classical theorems were Wilson theorem, Fermat's theorem and Euler's theorem. So we had few problems discussed under those theorems. Now we have an easy topic which is called as multiplicative functions. So let's get on to the presentation. So let's have the overview. An arithmetical function or number theoretic function. So arithmetical function can also be called as number theoretic functions, is a complex valued function defined for all positive integers. It can be viewed as a sequence of complex numbers. So you know the biggest set is complex numbers. So let's have the intro of multiplicative function here. So the number theoretic function, which I already told you in the previous slide, f is multiplicative. When can I say a function is multiplicative? If f of m comma n is equivalent to f of m into f of n, whenever m and n are relatively prime. So this idea is very important. You know what is relatively prime? That is, the common divisor is 1. So few examples. If they're going to ask you what is a multiplicative function with example, you can quote these two examples. Two examples. The constant function f of n is equal to 1 is multiplicative, since f of mn is equal to 1. 1 into 1 will give you 1, right? So the constant function 1 is always a multiplicative function. Second one, the function n raised to the power of k is also a multiplicative function. How can I prove that? F of mn is equal to mn whole power k, which can be written as when the basis. So you can, when I can split up the powers, n raised to the power of k, n raised to the power of k, which is equal to f of m into f of n. So these are the two examples of multiplicative functions. So now a small view of these multiplicative functions. We'll be using three functions here. One is Euler 5 function. There's Euler 5 function you already been familiar with. Then tau functions. Then sigma functions. So three types of functions, three types of definitions for it, and together how to solve it. So first let's have the look at Euler's 5 function. Let m be a positive integer. Then Euler's 5 function phi of m, this is the notation used for phi function, denotes the number of positive integers less than or equal to m and relatively prime to m. Next is tau functions. Let n be a positive integer, then tau of n denotes the number of positive divisors of n. So this is how I denote the tau function. D divides n, the sum of all numbers, that is d, where d divides n. Next comes the sigma function. Let n be a positive integer, then sigma of n denotes the number of positive divisors of n. So again, sigma of n is equal to summation of d divides n d, whereas there in tau function we had it as 1. Now tau and sigma functions. These two results carries more importance, especially in problems. So you have to memorize these two things, which is very essential for your problems. So first let's have the comparison between tau of n and sigma of n. Tau of n is equal to 2. You can straight away write it as 2. The answer is 2. When n is prime, that is when the number p is prime, you can straight away write the answer as 2. Suppose if it is raised to the power of p raised to the power of k, then I can write it as k plus 1. Suppose if it is like power of p1 raised to the power of k1, p2 raised to the power of k2, and so on. pr raised to the power of kr. How can I replace that? That can be replaced as k1 plus 1 into k2 plus 1 and so on into kr plus 1. So this is the actual format for tau functions. Now the same way, coming for the sigma functions can straight away be written as p plus 1 when that p is prime number. So you should always have an understanding between when can I write 2 as such as an answer, only when it is tau function, when the prime number comes. When sigma function comes, I cannot write it as 2, I have to write it as p plus 1. This we have already seen, okay, earlier. So n is equal to p when p is prime. And this is another result, p raised to the power of k plus 1 minus 1 upon p minus 1. So n is equal to p raised to the power of k. Now furthermore, n is equal to p1 raised to the power of k1, p2 raised to the power of k2 and so on till pr raised to the power of kr. How can I replace it? p1 raised to the power of k1 plus 1 divided by p1 minus 1. And again p2 raised to the power of k2 plus 1 divided by p2 minus 1 and so on pr raised to the power of kr plus 1 divided by pr minus 1. So this is the basic difference between the tau function and the sigma functions, whereas the condition remains the same, whereas the action what we are going to replace it shows the difference actually. Now just a small problem for your basic understanding. Compute the value of sigma function if n is equal to 28. So you know what is the value of sigma function. Sigma is denoted by this symbol, sigma of n. Okay. So now what will I try to do? First I'll check out whether this is a prime number or it can be factorized or whatever it is. Right. Now the factors of 28 are 2, 14. Right. There are two things I can write. 2 times of 14 will give you 28. The same way 4 times of 7 will also give you 28. But I'm not going to choose 2 and 14. Rather, I'm going to go for 4 and 7. Can you guess the reason? Why am I choosing 4, 7? Because the latter part cause they are relatively prime. I have to choose a number such that they are relatively prime. Right? So, if I'm going to take 2 and 14, what will happen? The common divisor between 2 and 14 is 2 itself. So, then I will face a problem. So, I will go for the other option. This is one category of problem. So now n is equal to 28. I am taking it as 4 into 7. So henceforth I will write it as the common divisor of 4 and 7 is 1 because they are relatively prime numbers. Now first I will sort out for 4, then I will sort out for 7. The factors of 4 are, what are the factors of 4? 1, 2, 4. Right? We know that sigma of 4 can be written as a sum of its factors. So 1 plus 2 plus 4 will result in 4 plus 2 is 6, 6 plus 1 is 7, so it's equivalent to 7. The factors of 7 are 1 and 7. We know that sigma of 7 is equivalent to 1 plus 7 is equal to 8. Now what do? 4 I got the answer as 7 and for 7 I got the answer as 8. Now I'll go to the sigma of n function. So sigma of n is sigma of 28. So what is sigma of 28? This 28 can be written as 4 into 7. So 4 into 7 can be splitted as sigma of 4 into sigma of 7. What is sigma of 4? Just now you calculated the value as 7. So sigma of 4 is 7 and sigma of 7 is 8. So 7 into 8 will give you 56 as the answer. Hope you understood. It's a very simple problem. So always choose the number which are relatively prime and then. Thanks for watching. We'll meet up in the next lecture. Thank you.